Producing enough energy to meet our needs has become a serious problem. Demand is rising rapidly because of the world's increasing population and expanding industry. Burning fossil fuels like gas, coal, and oil seriously damages the environment, and they will eventually run out. For a number of years now, scientists have been working out how we can derive energy from renewable sources, such as the sun and wind, without causing pollution. Today, our marine renewable energy, also called ocean energy, which harnesses the movement of the oceans. Marine renewable energy can be divided into three main categories: wave energy, tidal energy, and ocean thermal energy conversion. And I say a few words about each one. First, wave energy. Numerous devices have been invented to harvest good wave energy, with names such as Great Dragon, the Penguin, and Mighty Whale. And research is going on to try and come up with a really efficient method. This form of energy has plenty of potential, as the source is constant, and there's no danger of wave coming to a standstill. Electricity can be generated using onshore systems, using a reservoir or offshore systems. But the problem with ocean waves is that they're erratic, with the wind making them travel in every direction. This adds to the difficulty of creating efficient technology. Ideally, on the wave could travel smoothly and regularly along the same storyline. Another drawback is that sand or other sediment on the ocean floor might be stopped from flowing normally, which can lead to environmental problems. The second category of marine energy that I mentioned is tidal energy. One major advantage of using the tide rather than waves and a source of energy is that it's predictable. We know the exact times of high and low tides for years to come. For tidal energy to be effective, the difference between high and low tides needs to be at least 5 meters, and this occurs naturally in only about 40 places on Earth. But the right conditions can be created by constructing a tidal lagoon, an area of seawater separated from the sea. Then for 3 hours, as the tide goes out, the water is held back within the breakwater, increasing the difference in water levels until it's several meters higher within the lagoon than in the open sea. Then, in order to release the stored water, gas in the breakwater are opened. It pours powerfully out of the lagoon, driving the turbines in the breakwater in the opposite direction, and again generating thousands of megawatts of electricity. As there are 2 high tides a day, the lagoon would generate electricity 4 times a day every day, for a total of around 14 in every, and enough electricity for over 150,000 homes. This system has quite a lot in its favor. Unlike solar and wind energy, it doesn't depend on the weather. The turbines are operated without the need of fuel, so it doesn't create any greenhouse gas emissions, and very little maintenance is needed. It's estimated that electricity generated in this way will be relatively cheap, and that manufacturing the component would create more than 2,000 jobs, a big boost to the local economy. On the other hand, there are fears that lagoon might harm both fish and birds, for example by disturbing migration patterns and causing a pure of silt, affecting local ecosystems. There are other forms of tidal energy, but I go on to the third category of marine energy, ocean thermal energy conversion. This depends on there being a big difference in temperature between surface water and the water a couple of kilometers below the surface. And here this occurs in tropical coastal areas. The idea is to bring cold water up to the surface using a submerged pipe. The concept dates back to 1881